In this video, we're going to work some example problems related to finding the distance between cities based on the coordinates of those cities in terms of latitude and longitude. And so we're doing this in the trigonometry course because it's just an illustration of an application of the arc length formula in radians. And so you don't need to understand global coordinates for trigonometry, but I think it's still a pretty interesting application. And in the process, you can learn how to interpret coordinate locations on the globe. So this is how it works. You might be curious as to why the coordinates of a location on Earth are given in degrees. Well, okay, so as you probably are already aware of, there's latitude and longitudes, and these are just what these are latitudes are these circles, and these horizontal circles at different positions on the globe. They're all circles, right? You see, but the radius gets smaller. The radius of each circle gets smaller as you get towards the North or South Pole. Now, the longitude lines are these vertical circles, but they don't shrink in size going from like one end of the globe to the other. They're just these circles of the same size that are equally distributed around the globe. Okay, now whenever you want to specify a location of something on the globe, you're just specifying a crossing point of a longitude and latitude. Now, but to do that though, you can imagine, so yeah, these are latitude lines, but they divide these up, you know, these go down to, so this is 20 degrees latitude, 30 degrees latitude, but these get divided down to minutes and seconds, fractions of a second. So like if you wanted to specify the coordinates of the Great Pyramid, go look up the coordinates of the Great Pyramid, Google that, it's going to be down to like seconds or even like fractions of a second. But it's all about the position of something on the globe is a crossing of a latitude and a longitude. Where they cross, that's the position of something. Okay, but how do you specify a point like this? What do these degrees mean? What that's referring to is it's angles that have vertex at the center of the Earth. Okay, and if you're specifying the position of a latitude line, then you're giving an angle in degrees, minutes, seconds, but that angle you're going to specify either north or south, like north 30 degrees or south 30 degrees, and that's referring to north or south of the equator, the largest of the latitude circles. You see how with this here you could specify any latitude circle down to the fraction of a second? You know, imagine there's an infinite number of latitude circles, because there's an infinite number of potential, you know, fractions of a second you can specify. Okay, but what you can see is that when it comes to latitudes, you can say anything from 0 degrees to 90 degrees north, or 0 degrees to 9 degrees south. So it's like it goes from 0 to 90, 0 to 90 north, or 0 to 90 south, and that covers all potential latitude circles. All right, now longitude, you're giving an angle in this plane here to specify a longitude line, and the 0 position circle for longitude, so like the same as the equator but for longitudes, is called the prime meridian. That's the 0 degree point. The equator is the 0 degree point for the latitudes. This is the 0 degree point for the longitudes, and the longitudes are specified. You say either east or west, and they go from 0 to 180 degrees. So this would be 0 to 180, and they don't say here, South America, I guess that's west, and then this would be 0 to 180 east. And then again, you could go down to the fraction of a second to pinpoint an exact location. Okay, so what we want to do here is specify the distance, like you can think about the straight line distance as a bird flies between Panama City and Pittsburgh. Now, all these problems, we're going to be assuming that they're on the same longitude line, so they're not any distance east-west apart. just to keep it simple. So we're assuming they're on the same longitude line. So if we're assuming they're on the same longitude line, then what are we interpreting as the distance between these two as the bird flies? Well, we're thinking about the distance north-south from each other because they're on the same longitude line, right? Like imagine here's a longitude or a longitude circle. Here's a longitude, but we're going to be using we're going to be finding the distance between the corresponding latitudes to get their north-south distance from each other. Like imagine this is, I guess, Panama City, I don't know, and this is Pittsburgh. And so we want to find, this is the distance between them. Okay, but it's weird to think about. We're not looking at like this straight line distance. We're looking for this arc length. Even if there was a road that went straight from Panama to Pittsburgh, hypothetically, we would still be looking at the arc length. You know, it's weird. You think about, when you're driving on a sphere. So how do we get this arc length? Well, we use the arc length formula. What we need to do is, this is 9 degrees north. That's specifying a latitude circle. This is specifying another latitude circle. Okay, so if you go from 9 degrees to 40 degrees, you trace out an arc. We're looking for the length of that arc. Okay, and we're going to assume that the radius of the Earth is 6,400 kilometers. So all we need to do is, so we think about what's 40 minus 9, that's 31 degrees. So what angle is 31 degrees in radians? Okay, well, there's pi radians for every 180 degrees. Degrees cancel. 31 over, okay. So that's the angle in radians. Okay, so what's the arc length formula? S is equal to R theta. That's it. Very simple. So the distance between the two cities, the north-south distance, is 6,400 kilometers times this, which is unitless. So times pi times 6,400, so this is going to be in kilometers. 3,463 kilometers. Okay, Farmersville, California, which is on the latitude circle 36 degrees north, and Penticton, British Columbia, which is on the latitude circle 49 degrees north. Okay, well, they're 13 degrees apart with respect to the north to south, 13 degrees. So the radius of the Earth, what is 13 degrees in radians? Okay, so the distance between the two cities, about 1,452 kilometers. Okay, New York City, located on the 41 degrees north latitude circle, and Lima, Peru, located at 12 degrees south. So here, you just have to be careful because this says south. The previous problems, we had 2 north positions and then another 2 north positions here. So all this means is like, you could think of this is like a negative 12. So the degree separation and the latitude degree separation here is really, it's 41 plus 12. So they're separated by 53 degrees. Convert that to radians. Radius of the Earth is 6,400 kilometers. So okay, 5,920 kilometers.